Hello everyone. Already in four different parts we have discussed about qualitative analysis. But in this part 5 we will discuss a very important point which is called insoluble phosphate scheme. This is a very important point. Now name itself suggests this is called insoluble phosphate scheme. So when will you perform it? There are three conditions, and all the three conditions must be simultaneously fulfilled. First thing, as the name suggests, first word insoluble. So compound should be insoluble in water, but it is not performed when all the compounds are water, for all the water insoluble compound. So second word is equally important, insoluble phosphate. It means that as a negative radical, PO4 minus 3 phosphate should be present. Again, for all the water insoluble phosphate, we are not performing. So the third point is this scheme is performed after first two groups. So when these three conditions are simultaneously obeyed or fulfilled, compound should be insoluble in water, negative radical present should be phosphate, and first and second group are absent. Then after, instead of normally we are after that we are going to check third A group. But in this case, when these three conditions fulfilled, then we never check 3A group. But after the all the separation of your positive group, in your practical book, there is a separate chart called phosphate scheme is given. So positive ion should be detected from the phosphate scheme chart. So let me tell you, suppose your compound is water insoluble and as a negative radical from dry test, you have identified that PO4 minus 3 is present. Now in group T, you prepare OS in HCl. Now you check the first group, it is absent. You check the second group, again it is absent. So in normal circumstances, we go to the 3A group. But because it is insoluble, because PO4 minus 3 is present and first two groups are absent, so now you cannot go for 3A group. Instead, you should go for this chart given in your practical book. You can read here the title phosphate scheme. Now let me tell you reason why is it so. And it is also, this question is asked by you in a practical. Why we are performing phosphate scheme after second group? Friends, reason is that phosphate is insoluble in water, then we prepare OS in HCl. For all the insoluble compound, we prepare OS in HCl. Now you can see that in a first group, reagent is HCl, and in a second group also we add HCl. So overall medium is acidic. Insoluble phosphate remain soluble in the acidic medium. But you can see now you can see that from 3A group onwards, we are adding NH4OH. So the medium is now turned from acidic to basic. And this is a characteristic of insoluble phosphate that in basic medium, its solubility decrease and it fall out from the OS. So it gives us wrong impression that we are getting precipitates. So after third A group, I'm sorry, after second group, instead of going here, we will go to this chart. Now, what to do? So, this is the test given. Your OS plus NH4Cl plus NH4OH. As I said, you will get PPT. Now, actually, it is not PPT, it is your phosphate and add H2S. If you get white precipitates, then these six positive ions, zinc, aluminum, calcium, strontium, barium, or magnesium, can be present. If you get light pink color, it is indicating Mn, green PPT, chromium, and black PPT, then these four can be present. So, suppose you get a black PPT, so then you should carry out further separation, OS plus NaOH. Dirty green PPT, it's called ferrous, red brown, ferric, light green, nickel, blue PPT, cobalt. In the case of white precipitates, OS plus NaOH, you will get white PPT. Add excess NaOH, and if it dissolve, then there can be zinc and aluminum. But white precipitates remain insoluble in excess NaOH, then these four can be present. Suppose if you get these two, then further separation, perform further separation and determine which one is present. So you have to follow this chart and you have to identify positive ions. So see, all these positive ions are from the 3A group to 5th A group, because positive ions of or salts of 5B groups are always water soluble. So there is no question of that. So if we summarize the whole discussion, we can say that there can be three type of phosphates given to you. Water soluble phosphate. So there is no question of the performing insoluble phosphate scheme because your compound is soluble. Example, potassium phosphate, sodium phosphate, ammonium phosphate, etc. Water insoluble phosphate, but positive is present from either first group or second group. So in that case also there is no need to perform phosphate scheme. For example, lead phosphate which is from the first group, silver phosphate, copper phosphate which is a radical of second group, cadmium phosphate again second group, no need. But after second group, here water insoluble compound, but after second group, yes, you must identify your positive ion from only the chart which is given for the phosphate scheme. So examples are zinc phosphate, calcium phosphate, actually phosphate of all these ions. So they all are the examples in which you have to perform or you should perform insoluble phosphate scheme. So this is a very crucial point. And these questions, when will you perform the phosphate scheme? So you should remember those three conditions and three different kind of compounds having a phosphate. So these things you should remember.